make something. You make something for the first time, and then the whole another achievement list.
Okay, so does anybody remember the plum pudding model?
Yes.
I do.
What?
Sure.
It looks like plum pudding, and
It's the
like
name.
it's like a sphere with like protons and electrons like all within it, like how pockets are in plum pudding.
Okay.
Isn't that
Why?
like the
What
Rutherford model
was
or
the
something?
advantage of that model?
It explained like the charge.
Yeah, because once Thomson found the electron, they said, okay, there's got to be protons. So you also have to hearken back to where the word atom came from. Okay, so the word atom actually comes from the Greek words that means the atomist. Okay. Imagine this is a piece of aluminum foil. Okay? So the Greeks that were atomists said, okay, I take this piece of aluminum foil, I tear it in half. It's still aluminum. I tear that, still aluminum. Still aluminum. Still aluminum. Still aluminum. And so you keep dividing that farther and farther and farther and farther and farther. At some point, you reach the point where if you divide it any farther, it's no longer has the properties of aluminum. Okay? So this was the ancient Greeks. Okay? So John Dalton was the first one that actually came up with like a working model of the atomic theory. And one of the things, because he was a student of history, he went retro. And he went back and he took that word atom from the Greeks. And so that's why it was called the atomic theory. So in the early version of chemistry, atoms were kind of viewed as like tiny, tiny little Legos. And if you put those Legos together in one configuration, you would get an Oreo cookie. If you put them together somewhere else, you'd get a platypus. Okay? Put them together differently, you'd get an apple.
The two extremes.
Yes.
If you put a
Platypus are just jacked up. Anyway, they're cool, but it's completely jacked up. So
randomly generated.
basically the view was that you take these tiny, tiny little Lego blocks and you assemble them in different ways, you get different things. Cool. And in Dalton's theory, the atom was indivisible, like it could not be further divided. Thomson comes along, finds the electron, that model was out. The plum pudding model came along. So they said, basically, it's kind of like what Colin said. Here's this chunk, and you had a balance between the positive and negatively charged particles. Because here's the other reality that any atomic theory had to explain, was the stability of atoms. And atoms are stable. I have been teaching behind this desk since the fall of 1994. Okay? This is when I got this desk, fall of 1994. I've been teaching behind it ever since. So when I walk in this room in the morning, there's a lot of things that I worry about. This thing turning into a squirrel is not on the list. Okay? It's not there. I got to figure if this thing's going to still be a table. Probably when I retire, God forbid when that'll ever happen, it's probably still going to be a table. So how do you explain that this thing is a table? It doesn't degrade, it's a table. It's going to be a table for a long time. So the plum pudding model was cool because it balanced a repulsion and attraction. So there's a university in England called Cambridge, and this is where a lot of this research was being done. So there was a guy by the name of Ernest Rutherford. So, and this is all done in the physics department. The chemistry department always talks about the history of the atom, but what the chemistry department doesn't tell you is that everybody that was doing research on this, they were all physicists. The chemists were trying to figure out how to make a more pure version of cocaine. It's a true story. No, in the early 1900s, you could buy cocaine. Like you could go to a pharmacy and buy cocaine.
Man, the chemists had their priorities straight.
They did, well, that's where the money was.
Unravel
Okay.
the mysteries of the
Physicists, like,
universe
what are we gonna do?
or crack.
So,
Exactly.
now, because they were physicists, and this is like the classic story. So if you remember the work that Rutherford did, he took a piece of gold foil and he had a radioactive source like thorium-232 or something like that, that would emit these alpha particles which you could not see because it turns out they were the nucleus of a helium atom. And he would shoot this at the gold foil and there was a screen and you would see little flashes of light. Here's the very short version of this story. But Rutherford was a physicist, so here's the classic way that physicists view the world. You give a Volkswagen Bug to a physicist and you go, hey, what's the Volkswagen Bug made of? Physicist likes to smash things. So he goes, it's running into a wall. Cool. So he gets the car up about 20 miles an hour, smashes it into a wall, and go, oh, there was a bumper. Okay, cool. Well, if 20 is good, 200 miles per hour has to be better. So then he gets it up to 200 miles per hour. Bam! Smashes it into a wall. Oh, look, there's an engine. Cool. What's the engine made of? Don't know. Let's isolate the engine, and then we're going to get the engine up to 2,000 miles an hour, and we're going to smash that into the wall. Ooh, look, there's a piston inside. What's the piston made of? So then we're going to get two pistons moving around in a circle, otherwise known as a particle accelerator, and then we're going to smash the pistons together and then see what comes flying off of the pistons. That's how physicists view the universe. Okay? So he's a physicist. He goes, hey, let's smash stuff together, see what comes flying off. Cool. So,
The best part of physics.
what?
Smashing things.
It is. So these alpha particles, which they didn't know what they were at the time, just called them alpha particles. Started out they were a helium nucleus. That was part of the decay process. He shot them there. Most of the time they went straight through. So that would be like me taking this apple and throwing it against that wall, and 99% of the time the apple went straight through it. Okay? It would. So what would you conclude about the cabinets?
They're not there.
Mostly empty space. Okay? Now, every once in a while, this positively charged particle would come flying straight back. So what's the only way a positively charged particle can come flying straight back?
It hit something.
It also hit a positively charged particle. We'll continue this discussion on Monday. So,